we welcome you on the Asger 2019 conference. You can start.
Thank you. As you can see, I'm back here in Denmark, Copenhagen. I would have loved to come, but unfortunately the visa system didn't work, so I wasn't able to get a visa in time. But we'll have to do it this way, but I hope that will be okay. So thank you for coming, and today I'll be talking about this platform that we've built called Flow. So what I'll talk to you about today is the principles behind it, as well as how we built the system based on these principles and what it results in. So let's get started. Alan Kay is the inventor of Smalltalk, has been a huge influence in the computing industry in general. And some years ago, maybe 10 years ago, we started a new Viewpoint Research Institute. They said that today, just what you're seeing here with this presentation is built on so much stuff. Right? So we are going through Skype. The executables and the alerts for Skype is 100 megabytes. I'm using PowerPoint. That's 500 megabytes. And Windows is 10 million lines of code. So you can see that there's so much code just to be able to do this. There's no way anyone human can understand all of it. And Alan Kay's point is that that's a problem. We have to do better. And we have to basically try to reduce the amount of code we need to make systems like this. So he says we have to reinvent programming with better technologies, better languages, so that we can write software that is understandable for everybody. From our point of view, we share that goal also because a programmer can write that many lines of code every day, and doesn't really matter what language it is. So if you have a language where you can write a lot of functionality in a few lines of code, you are more productive. So when we designed the Flow programming language, we had this goal in mind, and we tried to make a language where we could express a lot of functionality in a few lines of code. Now, the next point is when you need to build a big system, hopefully the code will live for a long time. And when you need to build a system that will live for a long time, Max Kenneth Alexander comes up with this concept of code simplicity. What he says is that when you're building a big system, the most important thing is to keep the complexity down. The key principle is that the benefit or desirability of your change in the code is decided by what is the value of this feature in the future and divided by what is the effort of maintenance. So why is it maintenance instead of development? It's because if the code is living for a long time, the cost is going to be dominated by the maintenance of the code. Code that lives for a long time will be changed at some point, and that means that's the most important factor. So the result of this is that you have to really strive to keep the code simple. And in our experience, which is also what Max says, there are some mistakes you can do when you're building systems. The first common mistake is that you write code that's not needed. I think we've all of us have seen that we've implemented something that turned out it didn't really have any value. So don't do that if you can. The other problem is that you make code that's hard to change. So it's like write-only code. Since that the code will live for a long time, that's a problem because that means the desirability becomes low. And the last problem is that you can write code that is too generic. That's a little bit of a subtle point, but when the code is too generic, it means that it's harder to understand and it doesn't express exactly what the value is, so it can be harder to work with when you need to maintain it. And also a key point is that you should avoid rewriting code in general. So rewriting is sometimes required, but it's only in exceptional situations. So when we decide Flow, we try to keep these principles in mind to make sure that we could have code that's maintainable, simple, and easy to understand. The third thing I want to talk about is the Zen of Python. Guido van Rossum, the creator of Python, he designed Python so that it would be a great language for beginners. And one of the principles he has is that there should be one, and preferably only one way, and it should be an obvious way to do something. So, as you know, many languages come with multiple paradigms, and that means that there are many ways you can solve a given problem. But in Python, the goal is to try to make sure that there is one good way to do things. We try to adopt the same goal because if we need to build a big system, we also need to be able to build a team around it. And to be able to have a team, it needs to be easy to learn and get into. So from one perspective, when I talk about what flow is, it's basically a summary of all of these principles where we try to put them together into a programming platform that allows us to promote these principles and concepts. So in one way, flow can be seen as trying to reach the goal of having very few lines of code with a lot of expressivity in them, keep the code super simple so it's maintainable in the long run and so that you can change it, and at the same time make it so that it's easy for beginners to learn. So in another way to say the same thing is that flow is a small language. So really it is a simple language with just a few constructs. It's simple because we have everything being explicit. We don't have implicit stuff, and also it's powerful. So the power comes because you have these three things together that will allow a big team to work together to build maintainable systems in fewer lines compared to other languages. So in a different way, you can think about it as this is what it really is. It's based on standard ML. That's a functional language that has very nice mathematical properties. We took that as the core of the language, and then we changed the syntax to be curly brace syntax, which is more familiar to most programmers that come from C#, Java, or JavaScript. And then what we also did is that we added subtyping. So ML is based on a Hindley-Milner type system, which is great. But if you add subtyping, that will allow you to reuse code in more ways than without it. So in summary, Flow is a functional language. It has static typing and it has a familiar syntax. And also what's important is to talk about what we did not add. So we don't have any for loops or while loops, which sounds a little bit strange, but it's following the principle from the center of Python that there should be only one way to do things. And if you don't have for loops and while loops, you have to do something else to get iteration. And what we do instead is that we have fold, we have map, we have filter, and then you use recursion. So that's the basic way to get to manipulate things. That helps keep the code uniform, readable, and correct. We don't have off by one errors because you don't have these for loops with indexes like that. Another thing we don't have is that we don't have any null pointers and there are no exceptions. So when you've written a program in Flow, there are only a few ways it can crash. If you get out of memory or out of stack, if you have array out of bounds, or if you divide by 0. Also, we don't have any inheritance, so that the code is explicit and not implicit. And that helps a lot with maintainability and readability. So if you open a piece of code, you can clearly see what it does based on that file alone. You don't have to understand implicit syntax or any other aspects of it. Concretely, Flow is a platform that includes a compiler. It has a runtime with a JIT for x64. There's a standard library. We have a full debugger, single-stepping debugger. We have a profiler. Also, it is integrated into VS Code, Sublime Text in Emacs, and that allows you to have a decent experience when you develop the code. So let me try to run the first little program. Here you can see hello world. Maybe I can do it, make it a little bit bigger. Whoops, maybe too big. So we import the runtime. We have main function, and it prints hello world. Now I'll compile it and run it, and down here you can see we have hello world. To see a different example, let's try to open this program. This is one of the Euler problems. There is a website where you have a bunch of programming challenges, and this is one of them. This program is trying to find some numbers, two numbers. When you multiply them together, the result is a palindromic number, meaning it's the same backwards and forwards. I don't want to you don't have to read it, but I just want to give you a sense that it is using the C family syntax. It's an expression-based language. There are no return statements. We don't have that many keywords. So the code is short and it's pretty readable. And that is a key principle, that we want it to be easy to understand and explicit. The other thing about Flow which is special is that it's a multi-platform language. So the same code can be compiled for all these different platforms. It runs as HTML5 in JavaScript. We can also run on iOS and Android as native apps. You can run on the desktop, that's both Windows, Linux, and Macs. And you can also run it on the server by compiling it to Java. So that's one of the benefits of having a small language. That means that implementing all these backends is not that much of work. And also we've implemented the runtime on these systems so that we can have the exact same code render pixel exact on all these platforms. So you don't have that problem that you have to do if Windows, if this or that to adjust it. You can just write it once and it will run identically on all platforms. So what about the UI? So another way to think about Flow is that it's a platform that comes with a bunch of libraries. And the most important one is Material. So Material is a library, where the UI library that implements the Google Material Guidelines. So the Google Material Guidelines are similar to UI guidelines from Apple and from Microsoft. It's a set of guidelines for the UI that allows the UI to work well on both touch, on mobile phones, on desktop machines, and we implemented those guidelines in this library. It's based on a principle called functional reactive programming. Some of you may know React, which is also another example of this approach. And then we abstract the underlying operating system in terms of how to render stuff on the screen through F-form, and then we have what we call natives to bind to the underlying platform. So let's see how that works and looks. So let me find it here. So we have this program demos here, and when I run it, I'll just show you how it looks like. So here it is. There are a number of examples. Let's just start with Hello World. So when I click Hello World, you see Hello World, and then there's a close button. Okay, very simple. So let's look at the code for this thing. So here it is. So here we have the code. There is a function that constructs the UI for this screen you saw. It takes a function that we will call when we close, and then it returns the UI. Material is the type that contains the entire UI. If you can see down here, the implementation, basically we center two lines, where the first line is a text, where it says Hello World, and the second line is a close button. When you click the close button, it will call that close function. All right, pretty simple. Let's try the next one. Hello user, here we have a UI where I can type my name. And in the background, you can see that it will update my name. So how is this done? Let's have a look at it. Hello user. First of all, we construct a variable for the name called username. We make an empty string. That's kind of like a placeholder where we will put in the string. Then we open a dialog where we ask you to enter your name. And when you do that, this username will change according to what you type. And then in the main UI, we'll center two lines, where the first line is a select on the username, and when the name changes, we call this function, this is the syntax for a lambda, and that will construct the text hello, where we put the name in there. So select comes from SQL, it's a projection, it's a similar concept there, where you project a value to another value. So basically what this does is that it takes a string and converts it into a material, which is what we can display on the screen. At the end, you have the close function, and that's how that works. So the key thing is that this is a value, the entire UI is a value that has also the behavior inside it. So when I call this code, I will construct the UI as a value that I can then pass around and use as I want. And that's a core principle in this material library, that everything is compositional. So you can divide up the code into clear functions that contain all the behavior and the logic around that UI, and you can use it as it's a Lego brick. You don't have to put signals together. You don't have to tie objects together or anything like that. You have everything as a value, and that means it's easy to build complicated and engaging UIs and also reuse them in many different ways. So let's have a look at what material really is. Material is a type. So here you have the definition of it. It's basically a union, an abstract data type of all these different things. So you have text, you have icons, you have all the UI elements that you normally need in a complicated UI, and then you specify the parameters on how you want each of them to look. So you basically have a very nice way to build the UI, and the benefit is that since we follow the principles from the Google Material Guidelines, typically when you write your UI, it will look nice, and you don't have to go to graphical departments and get them to review the UI and so on. You can just code it, and normally it looks well the first time. So just to demonstrate the cross-platform nature, let's try to take that demo program and compile it to HTML as well. So here, compile it. There's a compile server, so the second compile is quick, and then it produces the HTML, and here it is. So you can see it's the same program now running as HTML, and we have the same as before. It updates as we saw before, and the entire thing works just fine. And let's go back here. So another way to think about what we did in this Flow platform is that we designed Flow to allow domain-specific languages to be easy to construct. So that's a key principle from Alan Kay's research project. He says that you should do T-shirt programming. T-shirt programming is that you should be able to express the core ideas so that it can fit on a T-shirt. And the way to do that is to have domain-specific languages for each of the specific problems you're trying to solve. So the way we do that is we have both embedded and external DSLs. Embedded means that they're written in Flow and you use them, just like the material library you saw before. That's a DSL. But also external DSLs, which are other programming languages where we have an interpreter or a compiler or something like that. And we've worked hard to make it easy to write those and get them integrated into the rest of the system. And this is a principle we use throughout the platform. So let's see an example of this. I'm going to switch to Renan Rhapsode. That's the e-learning adaptive platform we built using Flow. And you can see some of the principles there. So here, this is the program called Curator. And what I'm going to do is that I'm going to add a slide and give it a heading. This is my slide. And what I'm going to do is that I'm going to add a slider. So I'm going to add a slider. I'm going to give it a name. I'm going to call it number. Give it an initial value of 1. So now I have a slider. Okay, let's just make sure we can display the value as well. So now I have a slider here. I can then simulate it and see how it would work. And now I have a slider here. I can see a preview on the different screen resolutions, how it would look and behave. You can see its responsive design. The entire UI library is built so that it's very easy to build responsive design. And it's very easy because it's compositional to have all these previews. It's basically just to display the same value 3 times, and you get this for free. All right, so now we have a slider. Next, the key thing is that this slider corresponds to the slider we have in here in material. So that is exactly this value we have, which I wrote in the code before. But now that is one of those values, okay? The other thing I can do is that I can insert a calculated cell. So now I want to say, okay, let's do 100 times the number. So we can present that. So this is like using Excel syntax, and we have an interpreter and parse of that. Okay, so now we have that. If I simulate it, you can see also that it's automatically updated. So this is where the functional reactive programming comes in. This value that the slider operates on is a behavior, that's the term for it, and there is only one, and that's why it works like this, so that it automatically updates both of them. Similarly, I can insert a piece of graphics. Let's draw, what should we do, a rectangle? Let's draw a rectangle here, and then what I can do is that I can bind, for instance, the opacity of the color here. I'll bind this one to my number. So now I bind the opacity of this rectangle to my number, and if I simulate, you can see, as I adjusted, the opacity of the rectangle is automatically updated. So this is the power of the functional reactive programming that allows us to express this very easily in a compositional way. And one other key point is that if I copy this, then I can see what the underlying structure is. Let me see if I can find it. Here. So this is basically the value you saw before, the UI you saw before. This is an external block, which is a slider. Then we have a calculated cell, and then we have a prime graphics. So you can think of this, even though it looks like a document, this is really a DSL. This is really a domain-specific language, which allows you to express not only formulas like this, but also logic. So I could insert a choice block, if I can find it, here. And here I can set up conditions so that it's like an if statement. So you get the idea that by having this structure like this, we can define not only a UI, but also logic that goes along with it. In this way, it's a core principle of the Flow platform that we define these DSLs, and they don't have to be text, they can be UIs as well. And that gives us a great deal of power because we can reuse the code even in a nice UI. And just to show you this, we call it Wiki, this language. Here's the type for it. It's basically just like material before. You see it's an AST where you have the different types, and it constructs a syntax tree, if you want, of these values. And then you can interpret it in two ways. Either you can edit it or you can preview it. That's kind of like a different way to interpret the same program. So that's a core principle. Another example of this I want to show you is here. So here we have a UI that basically presents a table from the database. So normally when you need to do a UI like this, where you can do filtering, sorting, deleting, editing, all of these things, you need to write a lot of code to get all this stuff with search and all these features. Here, we don't, because the code for this UI is here. So this is SQL. This is the SQL schema. So what we do is that we have a SQL parser. So we pass this, and based on this, we construct this UI. So the programmer doesn't have to do anything but write the SQL. Then we have a compiler that will generate server-side code to interface to the database. It'll also write the code for the client side to retrieve and parse the data and build the UI to allow you to display the data, as well as the code allow you to change and update and delete the data. So you can see it's SQL, except that we add some comments that give hints about what you want. So for instance, there is a content field in the database, which we don't want to show it, so we say it's invisible, and there is no content field here. In this way, we can give it some tags and allow it to specify how we want to adjust the UI. So that's a very efficient way to keep the code T-shirt and the T-shirt principle, like Alan Kay said. What about security? Because if we do that, how can we make sure that people can't just change these organization in the database if everything is generated by hand, by the compiler? The way we do that is using another DSL that we call share key. So this is a DSL that defines the security rules for each table in the database. So here you can see two rules. The first rule is we allow users to create rows in this table. So everybody is able to create a new organization. That's what that rule says. The second rule says that allow users rights for this organization, assuming they have rights for projects. So there is another table called projects, which has its own access rights defined in this language. And this rule says that you will inherit those projects if the link between the organization and the projects is matching. So there are foreign keys between these tables, and then this rule will specify that you should follow those links, and if you have access to the project, you get the same rights for the organization. And the benefit of this is that then we know that the security is implemented correctly. Nobody's writing PHP or anything like that. The compiler is generating all the code for the server side to make sure that everything is safe and enforced on the server. So this is the example of how we use these principles and try to make sure we have as few lines of code as possible, and also make sure that it's maintainable and that it's easy to understand. So in summary, you can think of Flow as trying to solve this linear system of all these different things, where we try to put in the principles, try to keep it simple and allow it to be used by our organization with a big team of programmers to write maintainable and complicated systems. And if you're interested, go to the website and you can check it out there. That's it, and thank you for your time. Any questions? I can dive into any specific aspects you want me to. And let me just see if I can find the Skype here. I can't hear you, so if you're saying anything, I don't know.
Okay. Do you have any question?
Right.
My name is Andrei Terechov. Of course, you know me and I know you. But I wonder why you didn't mention about international team which took part in the implementation of this wonderful language. It would be interesting to listen here in Russia. Thank you.
Just просто напечатай. А можете повторить? Он напечатает на всякий случай.
So, they asked me to repeat this question. Maybe you can say several words about international team which took part in the implementation of this language.
I can see that some typing is going on. Yes, I can talk about the team. So in Area 9, we have around 100 programmers, and they come from different places. So we work with Planetacom in Russia, and we have a team in St. Petersburg, but also we have people that work from home from other parts of Russia. Also, we have a team in the Ukraine where we work with Intetics, and also we have a team in Italy. So we have a distributed team of programmers. Most of them are working with Flow every day. So when we recruit programmers, we give them a programming test, which they can solve using whatever language they want. And then we'll look at the result and evaluate whether they will fit into our organization. So in that way, it's a little bit of a different way because it doesn't really matter what your education is or what your CV says. We look at your ability to code. And if you can do that in a good way that's readable, understandable, maintainable, all of these principles, then basically you get a job. So once people are recruited, we have a training program where they get through a number of exercises to get them introduced to the platform and how to code in Flow and so on. It takes about 2 to 4 weeks for for a programmer to get up and running and be productive. So that works very well for us.
Thanks for the answer. Can I ask you? As I understand, this is already production ready.
Yes, of course, it's production ready, and it has been for a long time. So Flow was started maybe 8 years ago or something like that. It's in production. We have used this platform with millions of users. It's mature, and yeah, you can go to GitHub and download it and try it for yourself. And we use it for basically everything we built. So yeah, it's good.
Just right away without typing, because my page is quite long and you'll not be able to type it out.
You can come here and ask.
Okay.
Okay, wait a second, the man will ask you my question.
Okay.
Yes. Are you here? Are you hearing me? Is it fine for you to hear me? Do you hear me?
Yes, I do.
Cool, very good. First of all, thank you for the talk. That's quite interesting. And my question would be, I have like a few of them. First of all, you represent the entire full stack architecture from what I could understand, right? from the database up to the front-end tier. And what did transport in between? I mean, like, for server side, you deploy it probably as a Java application. Is that right?
Yes, so it is a full stack that covers everything from interfacing to the database, running on the app servers, and then the client. So the typical Flow program is a client-side heavy program. Most of the processing is done on the client in the typical program, and that's where you have the benefits of the material toolkit. And so what you do is that we have all these compilers that will take this SQL schema and then compile it into a bunch of different code. So that can be Java, it can be PHP, as well as Flow code. And that's how, so the typical way you write your application is that you define the database schema, then you compile this into the UI, and then you don't have to worry too much about the server side. So you can focus mostly on the client side and implementing the UI and the logic there. And then the DSLs for the database and so on will take care of the security and performance problems and SQL injections, all of those things that you want to make sure are okay.
But what server do you run?
So it runs on a LAMP stack. So basically it's Linux, Apache, MySQL, and PHP or Java. So it can run on any, we use Docker to deploy our software, so we can deploy it on any cloud that you need to.
And what transport in between the client tier and core and the server side?
So basically, you encode the data in JSON, or we have some more efficient formats as well that can be used, so that you will send the data to the client and it will process it and display it in the browser or your native app, whatever you want to use to deploy it.
Mm-hmm. Okay, thank you.
You're
Thank you
welcome.
much.
Okay, do we have any question more? Okay, Asger.
Thanks a lot for your talk and the answers. Probably if we will have a bit more, they will provide them to the Telegram chat, or we email you, or we can email right by email.
That's great. Thank you very much.
Thanks and have a good day.
Likewise, and I hope you enjoy the conference.